Okay. It's 4 o'clock. Why don't we go ahead and get started? For those who can't read, I suppose, this is Engineering 100. If you look around, you'll probably see about 450 people in this main classroom. We have another, I assume, I can't see them, about 50 people in the overflow classroom around the corner in the hall. You can go to either classroom, so for those of you who are watching on TV right now, you can come to this classroom on Wednesday or any day of the week that you, well, Monday, Wednesday for us, and grab any one of these seats. It doesn't really matter which section you were assigned to and which room you were told to go to. So another way of saying it, these seats are basically first come, first serve. All right. So why don't we go ahead and get started? I'm Professor Lacombe. Over in the other room, we have Professor Volstead. She's the other instructor or faculty member teaching this course. In addition to the two of us, we have a team of about 12 graduate students and undergraduate students helping us out. So I asked them all to come here just to wave at you and introduce themselves. In your individual skills labs, so this class has two parts. We have the big lecture on Monday, Wednesday, and then each skills lab will only have about 28 students or so. That's where you will see these guys. They will be the lead instructors for your skills lab. They'll effectively be your teachers that do all the fun stuff, like the hovercraft project that I'll be talking about on Wednesday. We also have a group of 3, I think it is, undergraduates who have taken this class in the past couple of years, and they've got a lot of experience about what works well, what doesn't work well. They've done the project before, and they'll be available to help everybody out just by going over to the EDL, which is the Engineering Design Lab over on the other side of campus. So we've had about 3 or 4 skills labs already meet today. We have 19 total. Many of you won't actually go to your skills labs until later this week, but I think we actually have 2 more later today. So you'll get to find out where the EDL is located. In short, it's up against Virginia Street. It's a complicated building. It's easy to go into a door that won't take you to our room. I recommend entering from the Virginia Street side of the building. And if you do that, we have some signs in the hallway with arrows and everything to point you in the right direction. Once you find it the first time, it won't be a big deal, hopefully. So, welcome to Engineering 100. We've got a bit of an outline. This is the typical welcome to UNR or welcome back to campus in the fall semester kind of a lecture. We have about 500 students enrolled. Last I checked, it was 501. And of those, I think about 80% of you are engineering, College of Engineering students, meaning that you listed your major as being engineering. About 20% are science, College of Science, and no, I take that back. About 9% of college are College of Science, and about 15% of the enrolled students are listed as liberal arts and humanities majors. So because this is largely a freshman course, over, I think it's 70% of you are first semester UNR students. We get the sense that you're still not entirely sure about what you want to do, right? That's part of what going to college is all about, is to figure out what kinds of classes you like and what types of things you might be interested in studying and then pursuing a career in it at some point. So we've designed this course first to be an introduction to engineering targeted to all the people who think they want to be engineers, but we're broadening it a little bit more to make it hopefully of interest to people who aren't sure and maybe are doing a little bit of window shopping. This course will hopefully introduce you to what the various types of engineering are and what the profession of engineering is all about. Most high school students have a little bit of an idea. Maybe you have a family member or a parent or something like that, or a friend who's an engineer. But odds are you don't have the full perspective on all the many different types of engineering there are, and we'll try to address that throughout this semester. So today we'll talk about engineering, generically speaking. I'll also give something that, especially if you're brand new, you probably got this ad nauseum in the orientation sessions. I will reiterate it one more time. How to be a good college student, study skills, these types of things. And finally, I'll talk a little bit about the class structure. These lectures that I'll be doing and Dr. Volstead will be doing on Mondays and Wednesdays are intended to be the big picture kinds of topics, whereas the skills labs, where there's only 28 of you at one point, that's where you're going to be doing the real engineering activities for the most part. So I'll talk about that a little bit more as we go forward. So that's me, Dr. Volstead. She's over in the other room. We're both here from the College of Engineering. I'm in the Chemical and Materials Engineering department, and Dr. Volstead she's a UNR graduate. She got her PhD and bachelor's degree here at UNR. She's got quite a bit of experience in mechanical engineering. That's what her degree's in. But she also has advanced degrees in education. And one of her specialties is engineering education, which is quite uncommon. So we're a bit lucky to have her involved with this class. Course team, oh, I should have shown this while they were still standing here. Well, that's them. We've got about 12 of them. Sorry, guys. In the back, we have two people who are still here, Ezra and Kira. They are TAs that some of you will have in your own sections. They're actually doing the videotaping for everybody in the other room, so you can all thank them if you're sitting in the other room. Hopefully, I won't walk around too much and lose them with the panning of the camera. So, all right. We're not doing this today, but raise your hand if you've gotten your clicker. Awesome, great. All right, so on Wednesday, we're going to do a test run with the clickers. What is a clicker? Well, it's about the size of a cell phone, maybe a little smaller than a typical cell phone. Looks like a calculator. Have you registered it? Raise your hand if you've registered it according to the instructions in Web Campus. Oh, only a couple of you. All right, so the rest of you are going to have to register it. And the reason for that is we're going to be doing quizzes in class where you're going to, I'm going to say, take out your clickers, and well, you'll see a question on the screen that says, you know, what day of the week is it, or something like that. And you have to answer correctly, and if you answer correctly all of the questions in one lecture, you'll get 3 points towards your final grade. The overall final grades in this class are based on 1,000 points, so 3 out of 1,000, but that's per class. When you add all the classes together throughout the whole semester, 4.5% of your grade is going to be based on your responses that you give right during class to on-the-spot quizzes. They're not going to be really hard. You're probably not going to have to do much math that you couldn't do in your head, but we're just trying to use this as a way to keep you engaged, and it also lets us know whether you were in class in the first place. So we use it indirectly as a way to do attendance. This Wednesday, next class, we're going to be doing like a test run. The clicker activity that we'll be doing there isn't going to be actually graded, but starting next week, really make sure that you have it not only purchased, but you've registered it, then you can come to class. And the reason you have to register it is because I won't know who to give the points to. Right? We have to know that that is your clicker, and you can do that following the instructions that we have in the course website. So. Okay, so what is engineering? Well, a lot of people will give you different definitions of what engineering is, and I'm sure you probably have your own idea about what engineering is, but one form, and this is from Wikipedia, which everyone knows is 100% true in all respects, engineering is the science, discipline, art, and profession of acquiring and applying, that's the important part, applying technical, scientific, mathematical knowledge to design and implement material structures, machines, devices, systems, processes that safely realize a desired objective or an invention. I mean, they just beat everything interesting out of engineering with that one. In my opinion, this is what it is, okay? You get to design stuff. And ask yourself for the moment, what is the difference between designing things and making things? All right? They're not quite the same. Those of you who are trickling in, we do have a fair amount of seats over in this section over here. Just excuse yourself as you step on people's feet. Another option is to just sort of stand in the back, but that gets old pretty quick. So engineering, what is engineering? Designing stuff and making stuff. They're related to each other, but engineers, we do the designing. Okay? What this means is we're not just tinkering and slapping together things by trial and error. There's some of that, I won't lie to you. I mean, engineers do use a lot of duct tape, no question about that. Right? But engineers, we practice science and math, and we apply the basics of science and math to do things intentionally from the get-go. There's always a healthy place to do trial and error of things. But engineering, the process of designing involves, and we're going to talk about this a lot this semester, involves the intentional use of mathematics and science and all sorts of other skills to achieve a certain outcome subject to certain constraints. Now, in the real world, what this means is a customer comes to you and says, I've got a widget, and I want you to make the widget for me, or at least design the widget for me. And they're not just going to simply say, I want the best widget in the world. They're going to say, it has to do this, that, and the other. It can't cost more than this. It has to interface with our Huzamawatsi. It's got to be blue. Whatever. They're going to have a set of criteria that you have to design around. It's never so simple that they say, you can have all the money you want, just go and make me the best thing. Okay? In the real world of engineering, you have constraints that you have to deal with, and there's a typical cost, time, and effectiveness are the three big constraints, and we have a rule in engineering. Cost, time, and effectiveness, pick two, right? Because you're not going to get all three. If you get all three, you're blowing the cost one, essentially. Right? So That's what engineering is. Tinkering really isn't engineering, at least not on a one-to-one match. They're connected to each other. Engineering is, as I said, and I'll reiterate throughout the semester and throughout the rest of your 4 years you'll be hearing it, is a process of applying methods, applying science, some math, all these other things, so that we can essentially predict how good something is going to be while it's still on paper and before your company has invested $100 million in building prototypes, doing market tests, and things like that. Okay? They don't make airplanes anymore by just throwing stuff together. Right? They hire 6,000 engineers to spend 4 years doing the calculations, planning things out very carefully, so that then when they actually start cutting metal and things like that, they've worked out at least as many of the problems as possible ahead of time. That's what the design process is. So that's what engineering is. So, by inference, who is an engineer? An engineer is someone who uses the tools of science and technology and other tools. You have to be able to speak and read and things like that, of course, to analyze and solve practical problems. This is really how we distinguish ourselves from the sciences. Engineering and science, they look an awful lot alike, but the sciences, all factored in, focus much more on the creation of fundamental knowledge, the discovery of new things. Engineers focus much more on doing useful things with it, practical things. It usually has to do with something to do with business, where you're trying to make a product, sell a product, maybe try to improve a product. Okay? Engineering provides a link between the idea that society needs something and that somebody actually stands a chance of creating a business model to make money off of it. That's the way it works, at least in the United States, where we have a capitalist society. We have market needs, and then we have commercial applications. And if they don't match, it never gets off the ground. A lot of great ideas will never get built because maybe we don't need them, right? Or maybe they're too expensive. We have yet to come up with a way to do it in a cost-effective way. So people who do these types of things, these are what engineers are. We tend to be fascinated by questions of how and why things work. Raise your hand if you've ever taken something apart and couldn't get it back together. All right. We're here to teach you how to put them back together, right? So engineers love disassembling things. These typically, these are the positive stereotypes. They know and love math and science. Now this one, I don't know that I would agree with, really. Love is a strong word when it comes to math for me, right? But you tend to at least be competent at it. You tend to, preferably you love it, right? But if you don't love it, you can at least tolerate it and you can apply it. All right? When I was in high school, I really didn't like math. I didn't really see what the point was until I got to college. For other reasons, I knew I wanted to be an engineer. Basically, everyone in my family said, you'd be a good engineer. As I picked my head up from the Legos and said, yeah, I think so. Right, so I didn't love math, but I did love science. And I discovered that with the right teachers and with the right examples and the right way to connect it to the real world, math really isn't all that hard. Okay? Engineering is just 4 years of word problems, and then the rest of your life as your career. Right? But it's real-world application of mathematics. Okay? And then finally, engineers generally want to do something useful with their lives. It has something to do with creating, with designing, which is a form of creation, right? Of improving the world around them, coming up with the better mousetraps, so to speak, right? Most of you are probably more mature than mousetraps, right? But you're thinking of solving third world hunger and clean water problems and renewable energy and all these other real world problems. The scientists get all the credit, but they don't do any of it. No scientists here, I can say that, right? The engineers, we actually get it done, to be honest, okay? We apply the science. They invent it. We make it actually practical, and we make it work. So these ideas of improving society, it really happens through the engineers that get it all done, all right? So that's who an engineer is. So why study engineering? Well, I imagine that each of you has your own reason that you're sitting in this classroom. Some of you maybe have made up your mind about your majors. Maybe some of you haven't, okay? But there's a lot of reasons, and the good reasons, I'll talk about some of the more crass reasons in a minute, but the good reasons have to do with the kind of an impact that you can make on the world. An engineer has the ability to change the world much more than almost any other profession you can choose. Now, if you pause and think about that, doctors, I would never knock a doctor. I've got several of them in my own family. They help people one person at a time. Engineers can help people and can change the world, societies at a time, by inventing new technologies, by inventing new ways of living, of solving hunger and all these other kinds of problems, right? Now, for many of you and for growing numbers, lots of research is showing this, that high school students these days, yeah, the money's nice, but they want to make a difference. And all us faculty are like, well, geez, why didn't we think of that? You know, it's absolutely true. Okay? So we don't want to say, be an engineer if you're good at math and science. Not anymore. Nowadays we say, be an engineer if you want to help a lot of people. Or be a politician, but that's a double-edged sword, right? They can impact a lot of big things, right? Everyone laughs when I say politicians. Go figure, right? But politicians, they have the ability to impact a lot of people's lives simultaneously. Engineers do too. And there's not a whole lot of professions you can really say that about. So, practical or crass reasons why you might choose a career in engineering. Well, even in this day and age of tough economic times and low employment numbers or high unemployment numbers, engineers tend to get about twice as many job offers as business majors, okay? 8 times as many offers as education majors, all right? 12 times as humanities majors. Engineers, if you graduate with a 4-year bachelor's degree in engineering and you decide you want to go to law school, your chances of getting in are better than people who have pre-law degrees. Same thing for medical school. Why is this? It sounds kind of weird, right? Engineers will beat it into you whether you want it or not, right? You have the ability to break down problems, to analyze very well. Your critical thinking skills after training as an engineer are going to go through the roof. And those skills, it is being realized nowadays that law schools need that. Medical schools need that. They figure, great, this is excellent starting material for medical school, right? We can mold you into being an actual physician or something to that. They like engineers, right? Engineering is a very powerful tool, whether you practice as an engineer or go into business with your engineering degree. I have had my own students go on into law school. In fact, I just met with one of my former students, graduated last spring. She's applying to law schools right now. I've had several students who are already in medical school and one who's already graduated from law school. Okay? These are not uncommon things. They're actually pretty typical things. The types of medicine and the types of law that they choose tend to overlap with engineering. People are interested in biotechnology, bioengineering, law, a lot of patent engineers. In fact, probably the majority of the really good patent engineers, actually patent lawyers, have engineering degrees on top of their law degrees, right? Because they have to understand the patents, right? It helps if they have an engineering degree. So there are a lot of practical reasons. And then here's one that you probably have heard. Lucrative college degrees. Not too long ago, CNN Money's website reported on a government release of data on the employment statistics. And they said the most lucrative college degrees, and here they're talking about 4-year college degrees, not like PhDs and things like that. Grab a pencil, calculator, and protractor, or drill. I don't know many engineers who drill a lot, but I guess engineering majors snagged most of the top spots. Same basic report led to this. And they say some pretty nice things about some other degrees until you really think about it. Overall, the average salary offered to graduates in the business disciplines rose 3% to $48,000. That's a starting salary after a bachelor's degree. While students in the computer science discipline saw their average rise 4.3% to 62 compared to 48 for business. Right? As a group, all the engineering majors saw a 2.5% increase, giving them an average salary of about $60,000. That's a starting salary. And they were nice to say that humanities and social sciences are getting more jobs, 15.3 increase in their starting salary. That 15% increase got them all the way up to 40,000 compared to the 60,000 of engineering. Okay. Why do the numbers break down like this? Well, engineers are in demand. Engineering is the engine behind our economy that drives the innovation behind which companies come out with better products, new companies with new ideas get started, and the people who make all this happen, the engineers, they're worth something, and there's competitiveness to get these jobs. You guys, I imagine, are here for at least partly that reason, where you want to have a job when you graduate, and preferably a well-paying job. A survey of starting salaries of bachelor's degree. The top 8 bachelor's degree jobs in terms of salary are all engineering. All right? You've got to go pretty far down the list to find accounting, history, English, psychology in these other areas. Okay? Not too far down the list will be other things like business and teachers. Teachers, unfortunately, are way down there, and that's the way it works. That's a sin, actually, but that's the way it is. Okay, so engineers, you probably have an idea of what an engineer does, especially if you have a family member or a friend who does this, or maybe a friend who's an engineering student. But there are actually a lot of different things that engineers do in their daily jobs, and the emphasis can vary depending on which company you work for, which position you take at that company. Some engineers spend all their time designing, but not all of them. In fact, most of them don't, to be honest with you. A lot of engineers do planning. A lot of them manage other engineers. They analyze things. They can check other people's work, for example. There's a lot of work there. Some do innovative, original research, more the inventing kind of things. Some do specialized problem solving. Most often they're consultants. Some focus on sales. Some are service engineers. I have a friend who works for an aircraft engine company, GE, General Electric. His job is to fly around the world. You know, Saudi Arabian Airlines has a problem with one of their jet engines. His job is to get on an airplane and go out there and fix it. And when he's done with that, he flies to Alaska. And when he's done with that, he flies somewhere else. Right? Anything that deals with the technical aspects of our society usually has an engineer's footprint on it, not only in the manufacturing, but in the support afterwards, the selling of these things. Engineers, when I say engineers do sales, I mean, they're not like, you know, selling hamburgers at McDonald's, right? They're selling, you know, multi-million-dollar computer systems or water purification systems or nuclear reactors and things like that. So they need to know the technical side of these things. Lots of opportunities. Many engineers move on to later in their careers where they'll do things related to management, supervising of other people. Many, many engineers start their own companies. They've come up with their own ideas, their own inventions, their own improvements to other people's way of doing things. Okay, so just because you have a degree in engineering doesn't mean that you're going to be sitting in a cubby like Dilbert. Do you guys know what Dilbert is? No? The cartoon from it's not so popular anymore, but 5 years ago, Dilbert was a cartoon you might still see. So you're not going to be stuck in a cubicle all day. All right? So what kinds of skills does an engineer have? Well, we're typically pretty good at critical thinking, judgment of other things. That includes questioning of assumptions, analytical thinking processes. But bottom line, engineering, as I hinted at a moment ago, is about finding the best way to do something, the optimal solution, given a set of constraints. The customer says that it has to be this big or this expensive or blue or whatever, right? And then finally, engineers are good at thinking outside of the box. You get it? Thinking outside the box? Yeah. I was up pretty late thinking of that one. So, thinking outside the box, what does that mean? Well, that's another way of saying creative solutions to problems that people have been working on for a long time. Or maybe creative solutions to inventing things that people didn't even know they had a problem with. Right? How many of you, or maybe you're too young to realize this, but ask people my generation, how many people my generation 20 years ago thought they needed a cell phone? Almost none. Right? Nowadays, we have a different attitude towards that. Some engineer along the line realized that, hey, we could do this, and all we have to do is price it accordingly, and enough people would buy the thing, a cell phone or whatever, and eventually it would become an integral part of their lives, and new features would be added, and now you have a way for, you know, to show pictures of your kids for $400, right, or whatever, and make phone calls. It's kind of funny. Cell phones, like these days with the smartphones, the fact that you can use them as a phone is almost an incidental thing. Okay, so engineering training. Did I skip something? No. Engineering training. The typical engineering degree is 4 years. You probably have all heard that. It's a bachelor's degree. Many, many engineers go on to master's degrees or PhD degrees. Engineering happens to be a profession where many companies, I used to say the majority of companies, I'm not so sure that's true nowadays, but I'd say call it 50%. Where I'm from, every company would actually, if their employees wanted to, they'd pay for their employees to go get a master's degree. Take night classes, things like that. They would pay for your classes while you're doing your regular job, and then after you got your degree, they'd give you a raise, right? Because the companies realize that having smarter employees generally means that they've got a better workforce. And as a result, they see it as an investment. And they get all sorts of tax write-offs because it's an investment in their own company along the way. But that said, a lot of engineers will get masters and PhDs. A 4-year degree is considered the minimum. And the way we go about doing it nowadays is with the university systems. I've known in my life probably one who actually practiced as a professional engineer, a person who did not have anything beyond a high school degree. All right? I was like my first year as a summer intern making blueprints in a civil engineering firm and during the summer. And they had their senior engineer had a high school degree and just learned engineering along the way. He's a civil engineer. And he, I don't know how, but he managed to become one of the best engineers around in the city where I worked. And he got his professional engineering license in civil engineer. But I have to say, I've known thousands of engineers. He's the only one who's ever done it. Managed to become a licensed professional engineer without having a college degree. Very, very difficult to do that. It was more common in the older generations. Nowadays, most everyone goes to the universities and gets a degree. There's a whole bunch of details, like accredited universities and things like that. You guys are all at an accredited university. We just got accredited for 6 years. That essentially means that a whole bunch of experts in the field of engineering, from industry, from other universities, from government agencies, came to UNR last year, and they put us through the ringer for a week. They looked at everything about every class in our entire program, and they actually gave us a full thumbs up, the best review we've ever had, in fact, and we're accredited for the next 6 years. So you guys get to be the benefits of that. What that means is that you will have an accelerated option for going on to professional licensing if you choose after you graduate. Your own departments will be able to talk to you as you become juniors and seniors about how important that is. In some majors, it's a big deal. In others, it's not such a big deal. Civil engineering, getting your PE, your professional engineering license, is a big deal. And you will be able to proceed through the process of getting that license, which usually happens several years after you get your degree, after you get real-world experience. So anyway, thought I'd mention that we are fully accredited in case you know what that means. All right, undergraduate study is probably the most important step in going along this direction. And you've got two options, and this speaks to your attitude as an engineering student, right? You can, one, do it the right way, and we'll do our best to help you through this, and acquire the engineering perspective and train yourself to be an engineer, right? What this engineering perspective is, it's hard for me to put my finger on it, but it involves everything from knowledge of critical thinking, basic math and science skills, all these types of things. Or you can just memorize and regurgitate things and become essentially a minion, a peon someplace, right? Engineers tend not to be in this category, but you have to sort of step up to the plate and develop, this is my pep talk part, right? Where you have to develop the right study habits, the right ideas behind what engineering is all about, and what I promise to do is to try to help you get to that point as fast as possible. It's going to take 4 years, okay? The process of becoming an engineer cannot happen immediately. We do have a different way of thinking, frankly. It's kind of scary when I walk into like dinner party type things. People know I'm an engineer without even opening my mouth. And I don't think it's the pocket protector either. I don't know what it is. So anyway, engineering is tough. I'm not gonna sugarcoat it, all right? Thomas Edison pointed out some 108 years ago, 9, genius is 1% inspiration and 99% perspiration. This is from a guy who has over almost 1,100 patents in his name. Right? He invented a lot of stuff. I don't know how familiar you guys are with Thomas Edison. He's a guy who invented things like movies. Right? He invented audio recording, the light bulb. Right? And these aren't little things in our daily lives nowadays. Okay? The list is ridiculous when you go down all 1,100 things that he invented. And his observation was that your intrinsic ability, and this is what you're bringing to us out of high school into this class, your intrinsic ability is helpful, but it's nowhere near enough, okay? What you develop for your further interests and your further skills from this point forward is really what will distinguish you as an engineer. And again, that's what we're here to help with, but you have to put the effort into it. You've probably heard the reputation about engineering being a challenging major. The rewards are strong. You make big differences in the world and you get paid pretty well for it, okay? But it's not going to be an easy path, and no one's going to sugarcoat that for you. And if they are, maybe you ought to turn a blind eye to what they're saying or wonder why they're saying it. They probably won't, but take it from me, you're going to work hard, but it's going to be a lot of rewards at the end of the process. So, please, look at being an engineering student, a student in college in general. It doesn't have to be just engineering. Look at it as being your job, okay? You'll hear some professors telling you something to the effect that you should be spending 3 hours of studying for every 1 hour you're in the classroom. That's ridiculous, right? So you're spending 45 hours of studying for every 15 hours of credits that you've got in the classroom. That's not realistic. But I promise you, if you take it seriously and look at it as a 40-hour-a-week full-time job, you're going to succeed. You spend 40 hours a week, legitimate hours, not BSing with your work team over in the library, not actually working. Actually studying and preparing, reviewing your notes, applying all the good study skills that we're going to try to give to you along the way, you're going to succeed. Okay? The vast majority of you are going to succeed if you treat it like a full-time job. Preferably, you'll put more effort into it than that, because hopefully it's going to be interesting to you. Right? Don't look at this as a party opportunity, 4 years of party on mom and dad's bill. I mean, that's obviously, I don't think I have to explain that that's not the healthy attitude. You want to try to make sure you develop all the necessary study skills along the way. And we're going to walk you through some of these things in these skills labs in classes. And I think that myself and all the other engineering professors in your other courses will help you develop these types of skills along the way. So put the time and the effort into it. I recommend that you don't take the approach of cramming for exams, right? Study class to class. There are piles of research about study skills that work well. And you're probably, many of you are thinking, yeah, I've heard all this before, but take it seriously. Review your notes from your classes before you go to bed that night. I'm not saying regurgitate it for 6 hours, right? Think about it. Remind yourself of what you covered. Spend half an hour to an hour reviewing your notes for all your classes before you go to sleep. You're going to retain a whole lot more of it than if you don't, all right? These types of things, those little tips like this can make quite a bit of a difference. Review these things each day, if possible. We, especially as engineering students, but really as humans, we learn by doing things. And by that, I don't mean, when I say continuous repetition, I don't necessarily mean copying things over and over. I mean by trying new problems, not just looking at example problems. By doing new things, doing many example problems. Okay? So try to apply these types of things. Right? If you don't, if you take the attitude that you can cram everything into your head, the 1 or 2 days before your midterm in physics or chemistry or calculus or whatever, it's not going to work. If you're naturally gifted, you might be able to float through, but you're not going to excel. Right? If you are gifted, push it that much farther. Okay? And procrastination, it's easy for me to say this. I'm probably the worst person guilty of it in the world. But that really is your enemy. When you're a student, you might have it, today you might believe me. 6 weeks from now, you'll probably say, no, there's no possible way. But this is probably the best time of your life, believe it or not. Okay? Once you go out there and you get a job and you got kids and you got bills to pay and things like that, every person, every practicing professional after college, every people I know, look back to their college days as, man, everything was so much simpler then. I only had 5 classes at one time to care about. Right? Things are only going to get worse. Try to develop good skills. That's terrible, right? It's only going to get worse, but you're going to get paid a whole lot better, and you'll be able to make a much bigger difference. All those things. All right, I didn't say that. You didn't hear that from me. All right. Engineers and their community. So I don't want to belabor this too much. We're going to see a lot more about this as we go throughout the semester. Engineers really fit into their communities quite a bit. We do a lot of things. I hinted at the kinds of ways that we can change the world. There are much more direct ways of getting involved, and we're going to introduce you to some of these throughout the semester. First off, I'd encourage you to give feedback to us if there's a problem in the course, either with the lecture or the course in general or in the skills labs. Please feel free to contact either myself as the lead instructor, Dr. Volstead, or even your TAs for your individual skills lab sessions with feedback about what's working, what's not working. Okay? At the end of the semester, you'll be given surveys for all your classes, including this one. Please try to be constructive in how well things are going. If you like things, tell us. If you don't like things, tell us. Okay? Because this is obviously a big class, and we want to try to have it run as smoothly as possible. You'll have lots of opportunities to get involved with professional societies. All these alphabet soups of letters here are various professional societies in engineering. American Institute of Chemical Engineering, American Society of Civil Engineers, IEEE, or electrical engineers, ASME, mechanical, Tau Beta Pi, honor societies. All of these are student-run organizations that get involved. They do public outreach, they do volunteer activities, they do fun stuff, believe it or not, like whatever is fun to an engineer. I don't know. I don't know, like ski outings and things like that. One thing about Reno is we have a lot of outdoor activities to do. So lots of things, lots of ways you can benefit. So you're probably sitting next to somebody who's not in your major right now. Okay, we have at least 6 majors. Some of these are really departments, not majors. Material science and engineering, chemical engineering, civil engineering, environmental engineering, computer science. Computer science and engineering, I'm not even sure still exists here as a major. They split it into computer engineering, something like that. Someone will correct me if I'm wrong, I'm sure, pretty soon. So why are you all here together? All right. Well, this course is an introduction to engineering class, and I hope you can recognize that there are common things that all engineers should know that aren't math or chemistry or physics or these other things. So there are additional topics. First of all, and the most importantly, is what is the design process? This is really what distinguishes us from science and those other fields. We're going to be spending a lot of time. In fact, this whole course is built around your hovercraft project that we're going to be talking about on Wednesday. Okay? And you're not going to be tinkering. You're not going to be slapping together. Well, who am I fooling? Last year we had people rebuilding their whole hovercraft the night before the final exam. But that notwithstanding, you're going to be designing a hovercraft starting in a couple of weeks, working as a team of 4 or 5 students working together. And This is an important part of what being an engineer is all about. So we're focusing on these in this class, and then we'll turn you loose to your various majors after this class. Okay, so our course philosophy is centered around our design project. It sort of subscribes to the old-fashioned adage that you can tell me and I'll forget, you can show me and I might remember, but if you involve me and if I actually do it, I'll actually understand what I'm doing. This is like, I know the Chinese say it's a Chinese proverb and the Irish probably say it's an old Irish proverb, but it's an old proverb. And we really do subscribe to it in this class because, again, this hovercraft project you're going to be making. You're going to be soldering things, you're going to be breaking things, you're going to be probably going through a lot of duct tape, you're going to be learning how to program using LabVIEW, you'll be trained on all sorts of safety procedures for how to do things safely. Last year I think we had no more than about 20 stitches all semester in the class. No one died, no one died. So safety is going to be a big important thing, and we'll get you trained up on all that kind of stuff. So it's very hands-on, right? Especially in your skills labs. So that stuff will be more fun. Why do we do it this way? Well, there's all sorts of educational research that suggests that if you simply read something, I don't know where these numbers came from, but I made them up. No, I didn't make them up. Reading, low level of actual retention and learning from it. Hearing it, above and beyond reading, a little bit more. Seeing things, maybe reading while someone else is, I don't know. You know, coming to class, seeing and hearing, I don't even know, how do you see and not hear? Somebody did this research and we thought it was a cute little figure. But the main point here is these last two. Okay? In engineering, we like when you work with others. Now there's a fine line between cheating off of them and working with them. We'll be doing our best as instructors to let you know where that line is. But generally, engineers are highly encouraged to work together. What you hand in has got to be your own work. So what's the difference? Well, you can talk about problems with each other. You can even say, what answer did you get? Right? But we want you to be able to arrive at that answer the same way they did. Right? Otherwise, you're not learning. Hopefully, that's kind of obvious. Right? It's not about copying off of each other. But there is so much learning that can happen. We call it peer learning, from student to student. You guys just have a way of talking to each other that I don't understand. Okay? You are at the same level of comprehension. You understand the misconceptions in a compatible way with each other. So working as a team studying is very important. And then finally, trying things and doing it yourself is critical. Many engineering students get caught in the trap of saying, Professor, can you give us more example problems? Well, yeah, sure, I could. But there's also lots of research that says people who study just by looking at example after example after example, they're not stretching their heads the right way of trying and failing. Right? You probably have been told, that one of the best ways to succeed is to fail first. You can learn from your mistakes. That really does mean quite a bit. There's volumes of research in education and how people think and how people learn to say that you can learn it the hard way. It builds character by doing it yourself. Okay, class structure for us. We have about 15 minutes. We're good. If you haven't figured it out, this class is broken up into two components. Our lectures, which is where everyone is right now, meets on Monday and Wednesday in this classroom as well as 103 down the hall. On Mondays, generally speaking, frankly, things have gotten so messed up over the years that I don't really know that we talk only about engineering as a career on Mondays, but that was the original envisionment. But we'll also talk about some basic things about working as a team on your hovercraft project. Things that we want everyone to hear all at once, and it won't be too detrimental to hear it from me instead of doing the hands-on part. You'll be doing the hands-on part, but you'll be doing that in your skills labs, okay? The skills labs are not in here. They are in the Jot Travis building, which is, let's see, probably due west of us, right on Virginia Street. If you know where the Davison Academy is, it's in the same building, except it's in a different section of the building. That meets for 90 minutes, roughly, once a week. And again, that's where you'll probably do most of the fun stuff over there. So, finally, many of you, and I sent out an email on this a few days ago, many of you might have noticed that you have a Wednesday 5 to 6 o'clock in the afternoon, late afternoon, early evening time slot for this class. But it says BTBA and RTBA, building to be announced and room to be announced. Don't worry about it, okay? What we did there is, because you are going to be working as a team, right? What we did is we reserved that slot in your schedule so you can't have any other classes. Now I know, and your teammates will know, there's 1 hour a week in which your team has no excuses for not getting together. Okay? because you can't have another class there because you're doing this class. You don't have to actually meet then as a team. But this way, you won't be able to hear from your teammates, sorry, I have a class in that time slot. There's 1 hour a week when we know every one of you is available to meet as a team. All right? Most teams will meet over in the JTB, in our engineering design lab over there, called the EDL. You'll hear me say EDL quite a bit. And you'll just meet over there. So meeting times are going to be important. You're going to see your teammates in your skills lab. So you're going to be put on a team of 4 or 5. Those 4 or 5 will be in your individual skills lab. So we're not going to be matching you up with people you don't see except in the 500 people in the classroom. So you'll spend a lot of time as a team right in skills lab. Okay, so looking ahead, we've got ourselves a little bit of a 10-day plan here. And I think I have time. I can show you this on Web Campus in a moment. Please, if you haven't done this yet, update your email in My Nevada. I'm getting lots of emails from people saying that they, or your parents or something like that, or from someone who says that they're now at a different email. Sometimes it's you. Please make sure that you use My Nevada. This is the campus system where you check your grades and you sign up for classes and stuff like that. Use that and configure your current and up-to-date email in there. If you do that, then it should trickle through and we should get that as an update. You're going to want that for all your classes. Otherwise, you're going to miss all of the important stuff. Second bit of homework. Please make sure most of you look like a purchaser clicker. Get it set up. The instructions are on Web Campus. I'll show you in a second. Okay? That means you have to register it to your name. It takes you like 30 seconds. It shouldn't take very long at all. But beyond that, and you'll get the instructions for how to do this in the course's Web Campus page. But go to the Web Campus and look around. Check out the welcome to this class kind of link. I don't remember what I called it. Read the course syllabus. In fact, that's one of your first homework assignments, is to read the syllabus. And I'm going to quiz you on it to make sure you actually read it. Okay? And it's worth points, I think. I think that one's worth points. If you have any questions or any problems, if you are not able to get in there and take the Web Campus quizzes and do your assignments, email either myself or Dr. Volstead as soon as possible. Like today. I don't mean don't wait till Wednesday, Thursday, Friday, because you're going to miss some stuff that we need to get done before that. So please do that as soon as possible. If you haven't logged into the course website yet, please do that tonight. Okay? We'll be able to head off, and if you can't, you'll discover that you need to talk to me, or preferably you can email me. You're welcome to talk to me after class if you already know you have a problem. But you can reach us by email. Essentially, anybody involved with the course, teachers, TAs, assistants, whatever, the address that you should send it to starts out with ENGR100 our last name @gmail.com. So it should be pretty easy. The hardest thing you have to do is figure out their last name. And our course website has a Contact Us and Find Us link where you can see not only the emails, but you can see our first and last names and all those types of things. Lastly, attend your 1.5-hour skills labs. There is a dirty rumor that goes around to incoming freshmen that labs don't meet on the first day of classes. Okay? That might be true, right, on the first week of classes. It might be true, but unless you hear it straight from your instructor, I wouldn't count on it. All right? So your first chemistry lab, physics, certainly the first lab here, we do meet. And if you miss that first class, it's going to suck. Because you have to get caught up. We have to get you integrated into our CATME system. All of you should have received an email from Dr. Volstead, I think it was, about a week ago. Might have been just recently, this weekend, from CATME, C-A-T-M-E. We're using this software tool to help create teams. Okay? The tool essentially asks questions that helps the software, the magical computer who never makes a mistake, to help design the teams as optimally as possible. So it asks you questions like, are you available between 7 and 8 o'clock on Wednesdays? Things like that, that help put teams together that actually stand a chance of cooperating and not having class conflicts and things like that. So please fill out that survey. It should only take you a couple minutes, and the software will use it to match you to people in your class. And the instructions for that came in that email from Dr. Volstead. If you did not get that email, you need to let us know as soon as possible. We might have like 5 minutes. If there's a class in here after us, then we're going to have to cut it short. But I'll try to talk to people after class up at the podium. And last year that was a disaster. We had like 50 people come up. Hopefully there aren't quite so many people. And if you can't get a hold of me today after class, or Dr. Volstead in the other room after class, then email us as soon as possible describing the nature of your problem, and we'll work you through it as much as we can through email. So finally, review your notes before you come to class on, not finally, we still have about 5 minutes. Review your class notes before you come to class on Wednesday. You'll have several assignments, including a reading quiz, that I would like you to take care of. So in this last 5 minutes, I thought I would just show you our Web Campus website for the course. So this morning in the Skills Labs, I asked how many actually logged on and did it, and it wasn't many of you. So okay, there's a question. Is the reading quiz on Web Campus? And the answer is yes. I'll show that to you in one moment. Whoops, what did I do wrong here? Username. Okay, so when you log into Web Campus, what you'll see first is something like this. You guys should probably listen up. This is going to be important because this isn't the only class that uses Web Campus. A lot of classes on campus will hand you assignments, they'll show you your grades, all sorts of stuff done through this interface. So this is a way for you to, and you can customize the interface if you want, for you to see what's due at any given time in any of your classes for that week. So I have a whole bunch of classes, but you'll see a list here, and you'll look at Engineering 100, Introduction to Engineering Design, and you'll see the class announcements that are currently there for you to read. If you click on that, it'll take you to the course web page. And the entry page is some useful information. What's new, like what things I've recently posted. What's due over here. I'm logged in as a teacher, so I don't have to do anything in terms of assignments. But you'll have a list of things, of something like 5 or 6 things to do already. Right? This first week, you have like 5 homework assignments. It's terrible. Right? Most of them are really easy, like go buy a book, things like that. Okay? But you got to do them. Okay? So go to the course welcome link, this right up here. You'll be able to see general introduction to the course. You'll have a link to the course syllabus. You got to read it because there's going to be a quiz on it. Your student contract, this is essentially so you know the rules of the game and how we're going to be giving you your grade. It's kind of like the syllabus, except it's a little extra stuff. How to get the course textbook. How do you get it? You click here and you download it. Okay? And you're going to have to actually fill out a form and submit it. It's on the different section of the web page, where you will go to the cashier's office and pay for it. Okay? But right now we have a preview version. Because of some software changes, the software versions have changed. The book, one of the chapters in the book is still being updated, and I was just told by the author that it should be done in the next couple of days. And you can download this. It's got everything except one chapter that you won't do until November or something like that. But we should have the final version available in a couple of days. And it will be quite fresh, right, hot off the presses, well, electronic presses for that. So here, a little bit further down, are the instructions for how to actually register your clicker. 10 short steps. Right? It's really not all that hard. You can look at the weekly materials link over here. This will have on a weekly basis of what is of interest for the class. So if you click on week 1 right now, you can get all of the slides that I just showed you in the week 1 Monday lecture slides. You'll be able to see Wednesday's lecture slides. You might want to print them out and bring them to class on Wednesday so you can make your notes right on top of the slides. So you don't have to, all that money you spent on your notebooks, you might not need them. Just print these out, bring them to class in a 3-ring binder, and you can have all of your notes. Hovercraft specifications, we're going to talk about that on Wednesday. Let's see, week 1. You can see your Skills Lab materials, like the slides and the activities and the homework done in Skills Lab. Very useful. Week 1 assignments. This is where you see the full list of everything that is going out as an assignment. Most of it's not due till next week. But so you have a clicker registration. I'm calling that a homework. It takes you 3 minutes. But you got to do it. Electronic textbook rental receipt submission. Get that done. You actually have more time. If you're not sure you're going to keep the course, you might want to hold off on submitting this. If you don't pay by the time the drop deadline comes around, you get booted from the class. But if you do know, like for example, the ad deadline I think is Thursday. Most of you know if you're going to stick with the class probably by Thursday. If you've made it that far, then you probably want to take care of getting the book paid for. Syllabus quiz, the student contract quiz. Electronic certification that you actually have read the rules and you know the grading schemes and what's allowed and what's not allowed. So it's pretty, administrative stuff, we'll call it. And then you actually are going to have a reading quiz. The electronic textbook, you'll be reading 3 of the chapters for next week, take the quiz, get your points, and move on. Skills Lab Assignment 1, you'll hear discussion of that in Skills Lab. You're actually going to upload the assignment. You're going to do it like in a word processor. You'll turn it into a PDF file, and if you don't, you get points taken off, right? And then you're going to upload it into the website. because it's a real hassle to grade 500 people's stuff if everyone calls their electronic file my homework, right? We got 500 files called my homework. So we have very special naming conventions. So follow the rules and you get all the points. It's pretty straightforward cookbook stuff. So some other shortcuts. As we go through the semester, I'll be pointing out that we'll be adding new links, things like that. But you can see your grades, schedule for upcoming stuff. That's all I got for today. Now, we'll see you either in your skills labs or on Wednesday. And if you have problems with email or anything else, please contact us as soon as possible.